science class. Before we begin, let's do a quick attendance check. Please say here if you are with us today. Giantri?
Here.
Bunga? Here. Sakitri Salama?
Here.
Ridwan?
Absent.
Okay. Thank you. I'm glad to see so many of you here and ready to learn. So today we are going to dive into the fascinating world of waves and sounds. This topic are not only important in science, but they also help us understand so many things that we are experiencing every day. So make sure you pay attention and take notes and ready to learn. Let's start with something simple. Have you ever noticed the ripples that form when you throw a stone into a pond? Or have you ever felt the vibration when you play music slowly? These are all examples of waves. A wave is a disturbance that transfers energy from one place to another without moving the material itself over long distances. For example, when you see ripples in water, the water itself doesn't travel across the pond. Energy moves through the water, creating a wave pattern. Waves are everywhere around us. They allow us to communicate, see, and hear, even feel. In this lesson, we will learn about the different types of waves, their properties, and how sound works as a wave.
Okay, previously we have already known what is wave for R, so now let's talk about the types of wave. So, there are two characters of wave. The first one is wave, and the second one is mechanical wave. So, what is electromagnetic wave? Electromagnetic wave is a wave that does not need a medium and can travel through the empty space. For example, it's like light wave, then radio wave, and X-ray. And otherwise, for mechanical wave, it's a wave that needs a medium and can travel through the air, the water, and the solids. For example, it is like sonic wave, then water wave, and seismic wave. But a mechanical wave can be divided again into two types. The first one is transverse wave. So, what is transverse wave? Transverse wave is a wave that the particle moves up and down perpendicular to the direction of the wave. For example, just like when you move a rope, the wave will be moved forward, but the rope will move up and down. Or we can make a graphic. It's like this. This is the line of the direction of the wave, and the particle will move up and down, up and down, up and down. This. And the second one of mechanical waves is longitudinal waves. What is longitudinal wave? So longitudinal waves is a wave that the particle move back and forth and follow to the direction of the wave. For example, when we speak, our voice will vibrate, and the vibrate will push the air particle and will create a wave to the listener ear. Or we can make a graphic like this. This is the direction of the wave, right? And the particle will move like this. Okay. See, you can see this is parallel to the direction of the wave, and the transverse wave would be perpendicular to the direction of the wave. Okay, for the next section will be presented by my friends. So that's all from me. Thank you.
Okay guys, now let's get into the properties of waves. By understanding these properties helps us explain why waves behave the way they do. So the first is amplitude. Amplitude is the height of the wave from its middle point to the crest or trough. The larger the amplitude, the more energy the wave carries. For some cases, a higher amplitude means a louder sound. And the second is wave length. Wave length is the distance between two consecutive crests or troughs. For sound, a shorter wavelength means a higher pitch. And the third is frequency. Frequency is the number of the wave that pass a point in 1 second, measured in hertz or Hz. Higher frequency means more waves per second. And then period. The period is the time it takes for one complete wave to pass a point. It is the inverse of frequency. And the last is wave speed. Wave speed is how fast the wave travels, calculating by multiplying frequency and wavelength. The speed depends on the medium. For example, the sound travels faster in water than in air, and even faster in solids. So now, let's try a quick calculation. If a wave has a frequency of 5 Hz and wavelength of 2 meters, what is its speed? So to answer this question, the speed is frequency times wavelength. The frequency is 5 and the wavelength is 2, so the speed is 10 meters per second. Okay, that's all from me. For the next session will be presented by my other friend. Thank you.
Waves can do some interesting things when they interact with different materials or with each other. Let's look at a few key behaviors. Number one is reflection. When a wave hits a barrier, it burns back. This is why you hear an echo when you shout in canyon. Number two is reflection. When a wave passes from one medium to another, like air to water, it changes speed in direction. This is why a show looks bad in a glass of water. Number three is reflection. Waves can bend around circles or spread out after passing through a small opening. This is why you can hear someone calling you even if they are around corner. Number four is interference. When two waves meet, they can add up to make a bigger wave, are called constructive interference, or cancel each other out, or called destructive interference. This is used in noise cancelling networks.
So now let's focus on sound waves, the Doppler effect, and real-life application. Now you must be wondering why sound can be heard. It turns out because sound is a propagating wave from the vibrating object as the sound source. There are three reasons why sound can be heard. The first one is sound source. The second one is propagating a certain medium. And the last one is frequency. So, for example, I am talking to my friend, and I am as a source sound, and my certain medium is the air. So, and the last is the frequency, my sound frequency. The fun fact is human can hear the sound from 20 Hertz to 20,000 Hertz. Above 20,000 Hertz, it's called ultrasonic. below 20 Hz is called infrasonic. It's used by elephant. Okay, that's all for the sound waves. Now let's move on to the Doppler effect. Have you ever heard the ambulance sirens? When it comes to us, the volume is higher, but when it moves away, the voice getting lower, or the ambulance sound is getting lower. It's because the frequency from the ambulance siren is changing. That's we call the Doppler effect. So this is the ambulance and this is us. If it moves away, it's getting lower. The sound is getting lower. And if it comes to us, getting higher. And this is called the Doppler effect. And for the real life application, for the Doppler effect, it's used in technologies. A lot of technologies used the Doppler effect, such as read your gun or read the car speed, and also the medical stuff for blood flow, and also the astronomy for the galaxies. Move to the real life application. We also know that music is using waves and sound, also communication, and also, how do I say that? Yes, such as like that. So, I think that's all for the explanation, sound waves, the Doppler effect, and real application. Thank you.
Thank you for your attention and participation today.
Remember, waves and sounds are everywhere, so keep observing and stay curious.
And for assignments, we will provide them in online classes.
Don't forget to submit your assignment in our online classroom.
See you in the next class.
Bye!